All right, so we're going to be going over the stock picker algorithmic challenge. And for this, we're going to take a user submission and kind of talk about their solution and maybe ask any questions or see any modifications we might be able to make. So I'm going to go to our pull request tab. I see a lot of you guys tackled this yesterday, so that's great to see. Let's see. Let's go with Mary Ann and Zach. I'm going to ask you guys to talk about your solution if you guys are up for it. So go here and then clone this down. So let's do a git cd git clone. All right, so we are using Mary and Zach's solution, code algo stock picker. Okay, so this is a stock picker challenge. Let's take a look at the README, make sure we understand what the overall goal was. So for this challenge, you need to implement a method called stock picker that takes in a list of stock prices, one for each hypothetical day. It should return a pair of days representing the best day to buy and sell. Days start at 0. So it looks like if we get an input of this, we should get 1 and 4 spit back out. Before we go to the solution, I think want to make sure we have some tests.
We have, I submitted in Python and she submitted in JavaScript.
Gotcha. Okay. Let's stick to Python since that's what we're focused on for this week. Thank you for that. Let's see. Mary, what's your GitHub handle?
It's data MAW.
Oh, wait. So Zach, you said you did the Python portion?
Yeah, so we worked on the challenges together, but we did Python first. So I submitted that one and then we went over and we switched roles and she did the JavaScript.
Right, so I committed the JavaScript.
Okay, so Zach, what's your GitHub handle?
Black Zachburn.
All right. All right, cool. Let's copy that down. All right, sorry for that slight hiccup. All right, there we go. So we have some code there. Great. You guys had unit tests also. That is great to see. So let's talk about this. So I'm gonna have your code up here. If you can kind of just walk us through your thought process. Great to see pseudo coding. Again, highly recommended for all of you guys. Hopefully you guys are pseudo coding either with comments or at least writing on pen and paper and kind of just going through your thought process there. So looking at their pseudo coding, we have first want to create a blank array to append the highest and lowest value to. Okay. Start from right of the list, subtract each iteration, create a placeholder. All right, so they're going to be tracking the highest value, also track the highest indices or index, and then compare the new answer to the placeholder. All right, I mean, that seems like a general algorithm I would expect where you have a temporary value. If you exceed your threshold or your criteria, you would update the placeholder, compare again. So that sounds like generally what I would have here. All right, Zach and or Mary, do you want to kind of just walk us through what you guys had here?
Sure. So name the function, the def picker. The parameter argument is prices, which is an array. And then high index, low index, max profit are like placeholders. So we declared the variables and set them to 0 for now.
Okay.
So then we did the for loop for items in prices, and we decided to go in reverse since we're subtracting the selling day minus the buying day.
Okay.
Just how it worked in my head. So let's say that is the selling day minus prices index is the.
Can you talk
least-
about this? Can you talk about this for loop? So this range I, can you talk about why you do range I and what that's kind of getting us? So let's have an example list up here, and then maybe you could walk us through what should be happening. So let's say our list is simply 1, 2, 3, 4, 5. Keep it simple. We're going to be iterating backwards here. So reversed range. So this will go start at the length. So I believe this will go index 4, 3, 2, 1, and 0. Let's keep this, make this 10, 20, 30, 40, and 50. Yep, okay, so these are indices. And we're gonna go in reverse. That's what they did with the reverse function. So we're gonna start with index 4, and that's gonna be our first item. All right, cool. So yeah, can you talk about what this should loop over?
Yeah, I'll make a note that we realized afterward reversing didn't really make a difference, but
That's all right, you guys got a solution, so that's the most important part.
So for J in range I, if we didn't do that, it caused it would take us too far to the right. We don't want to go further to the right than the for I loop.
So let's say for our first iteration, we're going to be iterating, our I value is 4. So that means here we're going to be iterating, J index will be 0, 1, 2, 3, correct?
Right.
Okay.
Yeah, which it wouldn't have made a big deal, I guess, to go to 4 that time. So it would have been 0, or would it have been out of range?
Well, yeah, if we went to 4 here, I assume we'd subtract the buying day and the selling day as the same day. So we'd buy and sell on the same day, so it'd be 0 all the time. So no, I think this makes sense. We're basically, as you said, iterating, we're checking every value to the left of the current day, as in a previous day from the current selling day, right? Okay, cool.
Yeah, exactly. And so then we set the variable profit equal to the selling day minus the buying day.
Okay.
Its price is J is the buying day.
Okay, that's yep, definitely good to note. Cool. All right, and then down here.
If the new profit is greater than the max profit, the variable up at the top, then that becomes the new max profit.
Yep. So that's generally a typical algorithm you'd see where you're trying to find like the highest or lowest or something. Generally have a placeholder, which they talk about up here in their pseudo coding. Yeah, this is eventually what you're going to return, or might return, I guess in this case. And if you exceed it, then you update it and then proceed on. So that'll be your new reference point. For this algorithm, we're just returning the index. So the max profit isn't actually returned. But again, that's our reference for determining which indices to store. Okay, so again, J is our buy day, I is our sell day. So that's why high and low are that respectively. Cool, and then they do have test cases. So let's give them a spin since they have they have plenty of test cases for us. So I'm gonna run Python. Let's get into CD Python. Python stock picker spec. All right, they have 5 tests. They all pass. Let's take a look at their tests to make sure we understand what they're doing. Okay, so they have, I think this is the initial test case that was provided in the README, I think. All right, so they're checking the type. Yep, so we expect a list to be returned in all cases. So that's a good test case. Test answer 1. 1 and 4 should be expected values. So if we kind of go through this manually, it says you want to buy on day 1, which is the second value here, and then sell on day 4 here. So looking at that, the difference between those three is 12. So you earn $12 in profit. If you try to quickly scan this, like, could you exceed that by any other subtraction in order? So like, we have a 1 here, which is great. That's the lowest value actually. So the stock will be the cheapest price on this day, but that's not necessarily going to be our cheapest or maximum profit, because we need the stock price to go back up, obviously. So it goes back up to 10. So it gives us a profit of 9, but that still does not exceed the difference here. So yep, 1 and 4 is what we expect. Here, the 3 is in seat number 0. And then looks like 18 is the highest value after that. So that would be our max profit. So I'd assume, yep, index 4. Yeah, so again, just verifying these test cases. A couple of questions that I know some students asked. For example, what if, stock prices were declining? So let's change one of their test cases, if you guys don't mind. Let's just say went from 50 to 40 to 30 to 20 to 10, right? Well, we didn't specify in our requirements exactly what we wanted to do. So in this case, looking at Zach and Mary's algorithm, they're setting their max profit to 0. So I think that should protect us actually. So actually, yeah. So I think this might be an error. No. Yeah, I guess this is going to return 0 and 0. But in this case, I would maybe, again, if I were coding this, maybe return none or something that specifies that no trading will be done. But I guess 0, 0 might indicate that. So let's see if this returns 0, 0. Yep. So in the event where no trade is placed, the expected value is going to be 0, 0, meaning we don't want to buy anything. And that makes sense because, again, it doesn't make sense to trade something if we're going to lose money, right? If the stock's declining every single day, no point in trading. So that'd be a test case I'd want to run here. But yeah, otherwise, great test cases, good algorithm. So well done there. Any other comments that Mary or Zach, you guys want to add here of like maybe things you tried or any other thought process you guys had?
I think we spent more time in the test cases trying to figure out how to match the result with an array or a list in this case than we did actually doing the algorithm. Matt helped us out a lot with that, but just in the test cases, test should return an array or a list. We spent a lot of time on that. It was kind of confusing on how to the self.assert equal type results list. For some reason, I could not figure that out.
Gotcha. Yep. I mean, yeah, unfortunate that, you spent a lot of time on that item, but hopefully, when it comes for the assessment, you guys are ready now to add that test case as needed or similar test case for the assessment. Okay. Yeah. So
I'll say too that originally, instead of just setting a variable to 0, I was overcomplicating it and I was pushing it to an array and was gonna make the index -1 the answer.
Gotcha.
But we kept getting errors that way, and this was a lot easier.
Gotcha.
So.
Yeah. Okay. Yeah. I'm trying to think what errors you might run into for that. I think for that use case that I had where you have negative or declining numbers, you probably never push into that array, and that may be one error that you encounter. But yeah, again, yeah. So many ways to solve this. Again, goal number 1 is to solve it anyway. You guys kind of came up with an algorithm. If you think it works, go for it. Don't never get bogged down in like, oh, is this optimal or is there a better way? Usually just attack the problem with something that you think might work and then improve upon it given time and any clarity that comes later. Okay, cool. So, any students out there have comments or questions for Mary or Zach?
Anchor, so I knew you mentioned don't think a better way. If your way works, you should do it. So I thought this very similarly, but instead of a nested for loop, I use 2 pointers inside of the for loop.
Yep.
But the logic is basically same. But could you think a better way to do this? I know this is not the most efficient way. Yeah, I just want to try use a better way. Could you show us?
Yeah, absolutely. No, actually, the way you mentioned is the way I think would be the better. When I say better, more efficient solution. So yeah, so just curious, feel free to raise your hand or whatever. How many of you guys did this with nested for loops, like the way Mary and Zach did it? Just random poll. I see some hands up there. Okay, I think maybe half of you guys. I'm not sure. I didn't see the whole class, but yeah. So nested for loops definitely works. Is probably the initial idea is like, okay, we definitely want to check each day against each possible other day. So again, definitely not wrong. This gives the correct answer, but the question is, can we improve upon it? And this is something we're going to talk more about a little more in depth next week when we talk about algorithmic complexity. Let's kind of introduce it now because I think this is a good challenge to kind of talk about efficiency. So the main structure here is we have two nested for loops, and that's effectively going to be something called n squared complexity. Or the way you'll see it, again, it's okay if you guys don't understand this notation, but you'll see notation like this. This means the way you read this is big O of n squared, right? What this is basically implying is as your data set grows, the time that this algorithm takes to run is going to basically be quadratic. So right now we have 5 elements. If we double that, well then our time complexity is effectively going to change by a magnitude of n squared.
And this is in the worst case scenario?
Yeah, worst case. Yeah, whenever we talk about big
Correct.
of n, that's generally worst case. Again, we're going to talk more about this next week. So if I lose you guys with this discussion, just kind of table it in your mind and definitely get back to it. But the main thing I want to highlight here is nested for loops. We're going through this list basically, sorry, how do I say this? Yeah, n squared times. So effectively, if we have something 5, we're going to almost go through this 25 times. That's not actually the case because we're cutting down some of the operation, but the actual equation or like number of runtimes is n squared, I think, plus n divided by 2, right? That's the number of times that's the number of iterations we're going to do here. The outer loops can provide a value of n as we go through our list. So if our list has 5 items, our n value is 5. The inner loop each time is going to go over like 4 times and 3 times and 2 times. That's why we have this plus n divided by 2. So if we had 10 items, like n equals 10, we would have 55 iterations. And you guys can kind of do the math. I might be off by a little bit, but effectively, if we have 10, we get 55. If we go to 100, this number becomes much larger. So this number grows much quicker than our input does, where n is the number of entries we have or the number of days we have, right? So Yaping mentioned she solved it a different way, and that's probably the way I would think about going this, again, for efficiency purposes. So it looks similar to this solution, but let me modify this and maybe see what we can do differently. Okay, so the key problem, and I put problem in quotes, is that we're looping through the same values repeatedly. So like when I equals 4, we're going through 0, 1, 2, and 3. When I equals 3, we're going to go through 0, 1, and 2 again. We already investigated those values and should know what they are. So we're kind of repeating work here by going through these values and then these values and then again these values again. Again, this is for a small input of 5. Imagine if we had 100 entries, right? That's going to be a lot more redundant work. So let's think about how to restructure this. So we still want to keep track of max profit. We still need to know low index and high index. But instead of nested for loops, let me try another approach. So I'm not going to go in reverse. I don't think it will change anything too much, but I just want to go forward. So range, then prices. All right, so that's going to be index values 0, 1, 2, 3, and 4. Oops, I got rid of my example here. We have 10, 20, 30, 40, 50. Okay, so what we're going to do here is first we want to know the price on this day. So we'll say current price is going to equal prices at value I. And then we want to keep track of our max profit. So to do that, let's see, if let's actually start at 1. So I'm going to add some special case here. So if prices equal or less than. So I'm going to check a special case. If we have an input that only has 1 day in it, we're not going to have enough data to determine when to buy or sell. So we're just going to return, let's return 0, 0, or return none, regardless. No trade's going to happen. All right, and then after this check, we're guaranteed to have at least 2 entries in our list. So this list will, this if statement will return if we have 1 or 0 items in our list. So at this point in our code, we know for sure we have at least 2 items. Therefore, I'm going to start my loop at 1 and then go to the length of prices. The reason I want to do that is because the first day, I guess we still need to check the first day, so ignore what I just said there. Current price, say low index equals 0. We already did that. What am I trying to do here? So I want to get the current price, check it again. Okay, so yes, I will start at 1. Sorry for this back and forth. All right, so we're gonna get the current price for day number 2. We're gonna check that against the low index, which is set initialized to the first day. Because the first day, no matter what, is gonna be your starting point, right? So I'm gonna do current price minus prices at low index, right? So we're trying to compute profit here. If that is greater than our max profit, which is initialized to 0, then we want profit to be equal to whatever this result is. So let's say potential profits equals this whole thing. Potential profit, right? That'll be our new max profit. If it's greater, then we want to update our low index to be equal to, or we want our high index to be equal to today, which is the value of I. But we also need to keep track of low index. So if we find a lower low, we want to update that. So here, we'll also have a check of if current price is less than prices at low index, then we want to update low index to be the current price or the current day. So both of these should be mutually exclusive, as in we should not need to calculate a profit if we know we have a lower price. As in day 1, let's say the price is 50, and then day 2, if it drops down to 40, well, we don't want to calculate profit because we know we went down, but we do want to update our lowest value that we've found so far. So if I go here, let's see. So current price, update low index, else, maybe do this. Again, I'm kind of piecing this together, so I might need to change some stuff, but all right, else potential profit. This is not going to work in all cases, but let me get rid of this stuff, right? So we'll update high index when we get a new max profit. We'll update low index when we get a new low price. However, this will not work in the case where we have maybe like 3, 20, 1, and 5. So this will get our max profit, but this will update low index to 1, which is not what we want. So I'm going to do something like low price equals 0. And I'll update low price here. Equals, let's see. Again, definitely gets more complicated without nested for loops. Low price index equals 0. I'm going to name these so buy index and sell index to make that a little more clear. So low price is just keeping track of the lowest price we've found so far. So low price will be prices at I. Any questions? I know I'm kind of throwing a bunch of variables here. So again, we're keeping track of our sell index, buy index. That's ultimately what we're going to return. Max profit is our reference. This value is keeping track of just the lowest price. It might not be the lowest price we're going to buy at, the lowest price that we're going to reference from this point on. Because again, the lower we go, that's going to be our reference point for any future profit that we can make from that day. Low price index. So we update the low price and low price index. Low index is sell and buy. All right, so again, my main goal here is to avoid repeating, going through the loop again in a nested for loop. So prices at low price index. All right, so we always will compute profit from the lowest price we've seen so far, right? Because that makes sense. To maximize profits, we will buy on the cheapest day. So we're keeping track of low price index. And that is the lowest price that we found in the past. Again, there might be a lower price in the future, but all of our reference points for the current price should reference the lowest value in the past. Price index. All right. So let's add some comments, make sure we know what we're doing. This is going to be if we get a lower price, update low reference. If the price has increased, all right, so if we get a lower price, we update that reference. Low price is not being used. Maybe we don't need that low price index. All right, might not need this. Okay, let's give this a run. Luckily, we have test cases, so if I broke their solution, we should be able to identify it. But let's see, we get the current price, check potential profit, we need to return buy index and sell index. Okay, let's stare at this for a moment while I try to see if there's any bugs with it. So current price, new price is lower, store that index. Okay, I don't think we need this value because we have the index that could give us the price. All right, whenever we find a max profit, we will update the sell price to the current day, so that's where we're selling, and the buy is from the previous lowest value. The reason we're doing this is because for this example here, we might find a lower price, which will update low price index. Like when we get from 3 to 20, our profit there is 17. So that's where we're gonna store as our max profit, and 3 and 20 will be stored down here. Next, as we continue our iteration, we'll find a 1, and that's gonna update our low price index. That's lower than our lowest price before, but we're never gonna update our max profit again because potential profit will never be higher than 17 because 5 minus 1 is gonna be 4. So maybe a better example is add some days in here. All right, so we start our loop. Again, always good to walk through our solutions with simple examples. We start with 6, and then that's what our low price index is going to reference 6. All these values are going to basically point to 6. We're starting our loop at 1. So we're looking at day 2 here, and then we get to current price. So current price is going to be 7. Then we're going to check, is current price less than the lowest price we've seen so far, which has been 6? The answer is no. So we've actually increased in price. So that's when we're going to update our profit. So potential profit is going to be basically 7 minus 6. And our new max profit, our old one was 0. Our new one is going to be 1. So now our highest profit so far that we can make is $1 or whatever unit we have. So we update max profit to 1. The sell index is going to be the current day, which is day with index 1. And then our buy price is going to be the previous lowest price, which was 6. We continue our iteration and we get to 3. 3 now is going to be our new low price index because that is lower than the previous low, right? So prices, the low price index was eventually 0, meaning our price value was 6. Now we have current price equal to 3. So our low price index is now 3. We're not going to check for max profit because we know the price went down. Obviously, we're not going to get a greater profit than anything we had before. Then we continue. We get to 20. 20 does not hit this use case because that is not lower than our lowest low. Then we get into our else branch. So current price is 20. keep in mind that our low price index was updated to 2 here, because that's where the 3 is sitting. So our profit here, potential profit will be 17. We compare 17 to our old profit of $1, right? $1 from this, 17 from this. So our new profit is going to be 17. Our sell index will be where 20 is, which is index 0, 1, 2, 3. And then our low price index would be 2. We continue, again, low price index would update from this 1, right? So that's lower than our previous low of 3, but we will never update our max profit again because nothing higher profit-wise is found. All right, so walking through that, I feel pretty confident about my solution here. Let me run Mary and Zach's test cases against that solution, and let's see if I broke anything. That is wrong directory, Python, stock picker spec. Wait, cool. So we ran 5 test cases, still passing them. So that makes me feel somewhat confident that I didn't break their solution or break the algorithm, but we definitely made modifications. So adding more test cases, making sure, we hit edge cases. Like if it's always ascending, that's a good test case. Always descending, that's a good test case. The special case I added here, again, good to check, again, error inputs. So don't always assume that your inputs are going to be valid. So in this case, if we have 1 day of data, that's not going to be enough for us to do anything. So that's maybe a good test case to add to your test suite. But okay, the reason I wanted to make this change was, again, now we're more efficient. We're only going through that loop 1 time. Now the slight trade-off here is we had to add 1 more variable to keep track of. Now that's not a huge memory hit, but again, if you're memory intensive and don't care about time, well then nested for loops will probably be the better and clearer solution. In this case, adding 1 variable isn't too big of a deal, but this saves us more time complexity. And again, we'll see the benefits. The larger our data gets, the faster and faster this solution will be over nested for loops. Because we are only going through our list 1 time, and there's no further looping in here, right? We're not searching anymore. We're just comparing values. And this makes our solution n time complexity instead of n squared. Again, if that makes no sense to you, totally fine. We'll get into algorithmic complexity next week. All right, so that was stock picker. Again, thanks to Zach and Mary for offering their solution, or I guess being voluntold to share their solution, but definitely good to see how you guys attack the problem. Definitely not wrong if you use nested loops. That's want to make clear. You were able to get a working solution. That was task number 1 and your main focal point here. As you code more and as you get into more algorithms, definitely just have that mindset of, okay, I got this to work. Can I improve it? Again, may not have time to do it. You might have other challenges to get to, totally fine. But just always be mindful of, hey, there might be some improvements I can make, whether restructuring my algorithm entirely or just making some optimizations of like, all right, maybe I could kind of return early out of this for loop or just do some other tricks that you guys will kind of get better with time. All right, so yep, that was just an alternate solution, slightly more efficient, but both solutions were totally acceptable. With that, any questions about stock picker? Did anyone else have a different approach to this? Curious to hear about any other solutions aside from nested for loops or kind of doing it this way where you keep track of a low reference price. Any questions about the solution here?
Could you show us how to do the same thing, but with an advanced function?
With an advanced, could you elaborate on that?
Sure. Like, is there a way to do it with like map, any sort of map or mapping?
Not map. So map is used when you need to create a brand new array based on an original array. In this case, we're not creating a new array based on our day input, right? So map would do would basically be like, what if we wanted to calculate the double value of the price from each day? Like we want to double each of these values. Map is used to create a brand new array based on your original array. So again, map's not going to search anything for you. It's just going to go from A to B where you tell it how to go from A to B. Filter would also not do the job for us because filter only looks at individual values. It doesn't really compare values or do anything like that. So I don't think we use filter here. The question is, can we use reduce? Off the top of my head, I can't think of a solution with reduce, but I'm not saying it's impossible.
You can use reduce if it's really fancy. I've seen it on Code Wars. It's one
Okay,
line.
cool.
Pretty
Yeah.
beast.
So reduce, again, if you remember, reduce kind of goes through each value and has an aggregator that keeps track of some memory. And you can use that aggregator to, I guess, would be your max profit, reduce. Actually, I'm not sure how reduce would work because you still need to keep track
Reducing
of-
JavaScript works. I haven't seen it in Python, but I think it would be about the same.
Yeah.
Yeah, if it
So
works
it
in-
sounds like, yeah, it is possible. I cannot come up with the solution off the top of my head, so I'm going to spare you guys that time here. But yeah, again, there's many ways to attack the same problem. So yeah, good thought there to use advanced functions. Any other questions, thoughts, comments? Okay, just to wrap up, key takeaway, solve a challenge any way you can. Don't get too bogged down in like, oh, is this efficient? Is this the best approach? Just focus on honing in how to solve algorithms. That's what we're trying to train you with all these algorithmic challenges. But with the slight amendment there, just still try to have the mindset, even if you don't get to optimizing or improving your solutions, just have the mindset of like, okay, I did this challenge. If I had more time, I might try to focus on this part and change it. And again, you'll get better with it and you'll get faster and faster where you can kind of pick out like, okay, this part's inefficient. Let me improve it because I have time to do it. Okay, with that, I'm going to stop the recording.